All right, let's talk about a true command line legend, a tool that's been a cornerstone for sysadmins since, get this, 1996, and for a really, really good reason. Today, we are diving deep into Rsync. Okay, so picture this. You've got a massive 10 gigabyte file, maybe a virtual machine image, and you just change one tiny little thing inside it. If you use a standard tool like SCP, you're sending the entire 10 gigs all over again. But with Rsync, you might only send 5 megabytes. So how on earth is that possible? Well, that's the magic we're going to pull apart today. To really appreciate why Rsync is so brilliant, we first have to understand the problem it was built to solve. And that's the massive inefficiency of what I like to call dumb copies. I mean, think about it, right? When you use CP on your local machine or SCP to a server, the process is incredibly basic. It reads every single byte of the source file and writes every single byte to the destination, every single time. If you're dealing with big files where maybe only 1% has actually changed, you are just burning a ridiculous amount of bandwidth and time for no reason. And this is where Rsync completely changes the game. See, it's not just another copy tool. It's a synchronization utility, and it's built on this incredibly powerful idea called delta sync. So here's the most important thing to get. Rsync isn't fast because it has some secret, supercharged network connection. No, it's fast because it's smart. It radically cuts down on the amount of data it needs to send in the first place. It looks at the file on both ends, figures out what's different, the deltas, and sends only that. But wait, it gets even cleverer. It doesn't just jump into that heavy-duty comparison for every single file. Nope. First, it does a quick check. It just glances at the file size and the last modified timestamp. If they're identical on both the source and the destination, Rsync just goes, okay, we're good here, and skips the file completely. This makes it lightning fast for directories with lots of unchanged files. Okay, but what happens when that quick check fails? That's when the real magic kicks in, the delta transfer algorithm. You can think of it like a little conversation. The receiving machine breaks its old version of the file into chunks and sends a list of checksums for those chunks. The sender then looks at its new file and says, hey, I see you've already got block 5, 8, and 12. Just reuse those. And here are the few new chunks you need. It's sending a recipe, not the whole cake. Now, the absolute secret sauce to this whole process is something called a rolling checksum. This is the genius part. To find those matching blocks, the sender doesn't have to do some massive, heavy calculation over and over. This special kind of checksum can be updated super quickly as it rolls across the file, making the whole matching process incredibly fast and efficient. It's what makes the whole thing practical. But there's no such thing as a free lunch. This efficiency comes with a trade-off, and this chart shows it perfectly. Rsync saves you a ton of network bandwidth, but it does it by using more CPU power on both ends to do all that clever checksumming and comparing. You're trading CPU cycles for bandwidth. Okay, enough theory. Let's get practical. Let's look at where you'd actually use Rsync and maybe more importantly, some of the critical mistakes you really want to avoid. In the wild, Rsync is just an absolute workhorse. It is perfect for mirroring your important folders to an NAS. It's fantastic for shipping those big Proxmox backups off-site. And if you've got a massive Plex library, it's the tool for keeping it in sync. You just pair it with an SSH key and a cron job, and you have a totally automated set-it-and-forget-it system. Now, let's talk about the one thing that trips up literally every single person when they start using Rsync. It's a single character that can completely change what the command does. We're talking about the trailing slash. Just look at these two commands on the screen. They look almost identical, don't they? But that one tiny little slash at the end of the word source, it makes a world of difference. This table nails it. A trailing slash, as in source slash, tells Rsync, hey, copy the contents of the source directory. But with no trailing slash, you're saying, copy the directory itself and put it inside the destination. Getting this wrong is how you end up with a messy dest/source/folder structure you never wanted. Trust me, we've all done it. But as annoying as that slash can be, there is a misunderstanding that is far, far more dangerous. It's a conceptual mistake that can actually lead to you losing all your data. I want you to let this one sink in. Read it twice. Synchronization is not a backup. Rsync's job is to make a destination look like an exact mirror of a source. A real backup is a historical snapshot in time that you can restore from. These are two fundamentally different things. And here's why that distinction is so critical. Imagine your files get hit by ransomware. They all get encrypted. Well, the next time your automated Rsync job runs, it's going to see all these new encrypted files and faithfully copy them over to your destination, completely destroying your clean copies. Or let's say you accidentally delete a super important folder, and your script uses the delete flag. Well, Rsync will do its job and dutifully delete that folder from your destination too. And just like that, it's gone.
So, keeping those limitations in mind, where does a tool that's almost 30 years old fit into our modern toolkit?
Well, Rsync's biggest weakness in our modern multi-core world is this. It's single-threaded. It works on one file at a time. Now, for a few huge files, that's totally fine. But if you have a directory with thousands and thousands of tiny files, like a Git repository, the overhead of starting and stopping for each little file makes it incredibly slow.
This comparative chart really puts everything into perspective. For anything going to the cloud or for handling tons of small files, a multi-threaded tool like rclone is just going to be way faster. And for real, true, versioned, encrypted, and efficient backups, you need to be looking at dedicated tools like Rsync or Borg. They have features like block-level deduplication and native versioning that Rsync was never, ever designed for. So here's the expert move. You don't pick just one tool. You build a strategy. Use Rsync for what it's the undisputed king of, efficient delta syncing between two servers you control. Use rclone for all things cloud and for those messy bulk transfers. And for your truly critical can't-lose-it data, you use a real backup program. So in the end, Rsync isn't outdated. It's not a tool that needs to be replaced. It's specialized. It's not a Swiss Army knife. It's a surgeon's scalpel. And for its one specific job, it is absolutely unbeatable. The mark of an expert is knowing exactly which tool to grab for the job at hand. So, now that you know, the question is, how are you going to use it?